let's go through this. For the equation of this line, what did someone get?
Y equals 2/3 x.
Positive 2/3 x?
Yeah. Plus 1.
You agree or disagree? Yeah.
Mine is different.
What is yours?
It goes through 0 instead of 1.
Okay, yeah, that's what I was thinking. Some of them may go through 0 and some may go through 1. Whichever your y-intercept is, but is the slope correct? It should be negative. So if your y-intercept is 0, leave it as 0. If your y-intercept is 1, then leave it as 1. I think like the line shifted on some of them, but not on others. I don't know. For number 2, the slope of the line that passes through these 2 points, how would we find this? Could graph it. How would we find it algebraically? 2 minus y1? 2 minus x1, or you can switch them as long as you switch them both. So 3 minus 3 and negative 3 minus 4. This would give us 0 over negative 7, which would give us 0. I'm going to do these in order. For number 3, this is going back to when we were doing exponents. If we are dividing like bases, what are we doing with the exponents? Subtracting, but then we're actually dividing the numbers. 3 over 27 would give us 1/9. C to the 9 over C to the 4th would be C to the 5th. And D to the 3rd over D to the 7th would be D to the 4th. If you separated it and then found the final answer, that was fine too. Questions on those so far? Number 4 was a combined like terms, so distribute. We get 3x plus 10x minus 12 minus x minus 2. We're subtracting here, so this would be d to the negative 4, but then if we rewrite that, that would be 1 over d to the 4th. So the d to the 4th would go into the denominator. So if we combine our like terms, 3 plus 10 will give us 13. 13 minus 1 would give us 12. Negative 12 minus 2 would give us negative 14. And then number 5, graph the inequality. What type of line would this be? It would be vertical, dash or solid, dash, and then to the right or to the left. How would we shape? To the right. Everything greater than. So at 1, you have a dashed line that is not straight. Shaded to the right. Other shortcut questions? Really quickly, I wanted to show you this. So this is one of the Khan Academies is due this Friday. The divide polynomials by x with remainders. We've kind of done this before, but not at the same time. With this, you may not be able to factor your numerator, so you would do the method that we talked about at the beginning of dividing polynomials, separating it and dividing each piece. I'm going to rewrite this first. we have something like this, you would take each piece, separate it, so we'd have 5x to the 4th over x plus 9 over x. And you would simplify what you can. Some of them may not be able to be simplified. 5x to the 4th over x would be what?
5x.
5x to the 3rd. Can we simplify this? No. We have two different bases. We can't do anything with exponents. So that would stay the same. So when you put in this answer, it's going to look just like this. So 5x to the 3rd. Oof, I can't see that. Plus 9 over x. All of them will be similar to this. The other dividing one is like what we were doing on the second page of this, where you have a polynomial divided by a binomial, and you have to factor it and find the remaining factor. Did we have any dividing polynomial questions that we wanted to go over? Did you have a question about anything before we switch gears and jump to our new notes for today?
And we were number 9 on the left page.
I thought I had this up here, but I don't. On this page or on this page?
On that one.
On this one. So for this number 9, you may or may not need to rearrange this so that this comes first. I say you may not need to because if it's constant first and this last, then that doesn't really matter. You're still going to multiply first and last. The middle term is still in the middle, so that wouldn't matter. But if it's not in that order, so if like your constant is here instead, then you would have to rearrange. You should be able to do it either way and get the same answer. So if we left it 1, we can divide out a GCF. Usually we divide out a negative or positive depending on the first term. So for this one, I'm going to consider 16 to be my first term and just make it a positive 8. So that would leave negative 1 plus r plus 2r squared. You can also factor this out, factor a GCF out of the denominator. And again, I'm going to pretend that the 8r came first. That's why I only factored out a positive, not a negative. Writing it horizontal sometimes is confusing, so if you want to rewrite it as a vertical, you can do that also. So then a couple things would happen. 8 divided by 4 would become 2. We would still factor out the numerator and see what's left. So we're looking for two numbers that multiply to be -2, but add to be 1. -1 and 2. So then rewriting that, I'm going to leave it still in the same order, -1 minus 1 r plus 2r plus 2r squared. And then I could divide out a -1 here, leaving 1 plus r, and divide out a 2r here, leaving r plus 1, which is the same thing, they're just backwards. So we have 1 plus r, or r plus 1, and -1 plus 2r. And now we see those would simplify. But if you didn't factor out a DCF, then it wouldn't. We have 2, and then I divided these here. These factors would cancel, so we'd end up with 2 times this. And then we could distribute that out. If you didn't factor out a GCF, I think you would still get the same answer, but you'd end up with a bigger number here, factoring wise, and then you would end up getting rid of this to get that. So there's more steps involved because you had to factor out a GCF, but it's still the same process. Did that make more sense, Audrey? Do you have any other questions in these? Before we jump into this, I do need to say this. I did find out your SOL date. It is May 18th at 11:20. All of you are taking it at the same time. I want to say it was in the library, but we'll talk more about that closer it gets. So moving forward, I do have a course calendar for you. It's just not printed out yet. So as soon as I get that, you'll have that. That way you can kind of see what we'll do for the remainder of the year, really. So this will be the last full unit, but we'll also be doing SOL review within that. And then after we finish this quadratic piece of the unit, everything else we do will be last minute things we have not talked about. And we're just going to combine that all into one thing, one unit, but also be SOL reviewing at the same time. So not today, but next class we will be incorporating more SOL review. There's some things on this page that you don't need to know and some things that are, but I'm just going to pull this down so you can copy everything. Because the first thing you need to know is that we're dealing with quadratics. We've kind of been dealing with quadratics for some time, but we never actually said that word. All quadratic equations are written in this format, either with a y or with a f of x. They're both the same thing. But where we have some ax squared plus bx plus c. So that should look familiar from all of our factoring stuff. With trinomials, anytime we factored a trinomial where the first term was squared, that was a quadratic. Anytime we had something that was squared regardless, that was a quadratic. When we graph quadratics, they are U-shaped, and we usually call that U-shape a parabola. And there are two different directions a parabola may go, up or down. And that is dependent on the a value in front of x squared. If the a value in front of x squared is positive, it will go up. If it's negative, it will go down. So on the graphs given, you can draw like a rough sketch of it.
Supposed to be dashed.
This line right here, we're going to talk about that here in a second, but that line is basically invisible. That's why it's dashed. We won't actually see that line, but we'll also be able to see it at the same time. That'll make more sense when we do it. Anyone still need this part? That line that you were talking about is called your axis of symmetry. It's a vertical line that divides the parabola into two pieces or equal parts. So we won't actually draw in that line, but you'll be able to see where that line is because it'll kind of split the view in half. There is a formula to find axis of symmetry. It is this. X equals negative b over 2a. When we get to the test after the SOL, you will need to know that, but we will review that later. When we use this formula, we get some number, and then we write our axis of symmetry as x equals whatever that number is. Thinking back to our shark bite, if we have x equals some number, that would be some vertical line. We use our axis of symmetry to help us find, our vertex. The vertex is the turning point of a parabola, but this is usually your minimum, the lowest point, or your maximum, your highest point. That's the part you don't really need to know about the minimum, maximum. We just need to know how to find the vertex. But because we're given our x value, we're going to put that x value back into our equation and find our y. Aubrey?
Can we do it on Desmos?
Yes. You can do the formula on Desmos and it would just give you an answer. The quadratic itself, when you graph it, it will plot 5 certain points. The vertex will be one of them. So you'll be able to see that point without really doing the work. You can always check yourself in Desmos. Does anyone still need this? We're going to do some of these examples and then move on to the graphing. So axis of symmetry, your A, B, and C values are going to be found in your quadratic. Just as a reminder, whatever is in front of x squared is A, whatever is in front of x is B, and whatever is last is C. So for using that, I'm using the axis of symmetry formula. it is always negative no matter what, kind of like slope. So we're going to put in a negative 8 over 2 times, what is our a value? 1. And figure out what x equals. What would x equal? -4. So then you would use that to find your vertex. So we could do this by hand. We're just going to use our calculator, but we have to set it up first. So when you set this up, you're going to start with your equation, y equals, and it's like you're evaluating, but with your axis of symmetry. So -4 squared, put x in, or this value of x in for all of your x's, plus 8 times -4 plus 15. And then you can use your calculator, put that all in, and find your answer. Make sure you have your square on the outside of your parentheses. Make sure you're using parentheses. Say that again. So we all got? So you would write your vertex as an ordered pair, starting with your x value, -4, and then your y value, -1. Yeah. Now, the rough sketch part is really just that. Yeah.
Is that the, actually the 15, is that a plus?
Yeah, it's a plus. They put that in their calculator, put all of this in the calculator and found it.
I mean, why is it starting?
Oh, because it's an ordered pair, x, y, and you need this x value.
Oh.
For your rough sketch, this is to help you determine, is it facing up, is it facing down? Where would it start? So you could draw in x and y axes. And draw in this vertex. You can make that as small or as big as you need to. So -4, -1. This has a positive a value, so that's going to mean it's facing up. It's going to look something like this. So it's really just for practice, so that you can see, is it facing up, is it facing down, where does it start? Yes, Sabina. Yes.
Like when you're drawing it, tell me where it is on my way.
Okay. We're going to do just a couple more on the next page. So we'll do 2. Oh, those are all my guys. So all of these are the same process. You're going to use that same formula to find your axis of symmetry, and then find your vertex, and then do a rough sketch. If you need to rewrite your formula, write that up here. Our b value would be what? 10, but in this case it'd be negative 10 over 2 times what's our a value?
-2. Oh, sorry.
The denominator would be negative 2, but negative 1. So x equals
Oh,
5. And then you're going to put that in to your formula, or to your equation. 1 equals, there's a negative on the outside, but 5 isn't negative, plus 10 times 5 minus 22. I need to get you the first page of notes, so remind me, so don't forget. So, yes, because it was already here. So it'll be 25 and then negative 25 if you were doing it by hand. 22. Double like that. 52. I'm going to say neither of those is correct. Sounds better. Make sure you're putting the negative on the outside though.
you just added this.
Say that again.
You just added this.
Yes, I do. Should it be 25? Because it is negative 25 plus 15 minus 25. I got 2. That is, oh, yeah, this is 25 minus 20. So yeah, this here. So then your vertex would be at the point 52. Would this face up or down?
Down.
Down, because this is negative, your a value. So our vertex, we could put that point at 5, 2, and it would face down. Do you have any questions so far? After we do a couple more of these, I am going to show you in Desmos how that would look. For number 6, how would we set up our axis of symmetry?
Equals negative 12.
Minus and minus. So you can put plus 12 if you want, but over 2 times 2.
Three.
I heard 3 and I heard 4.
Oh, I was just thinking about
It is, it's 3, yeah. And then find your y value. That sounds right. Is that what everyone got? Negative 9. Would this face up or down? Oh, because this quadratic. Negative 9 is a lot, so. Something like that. We'll make more accurate graphs here in a little bit. right now, as long as you know where the vertex and if it faces up or down, that's questions on 6 before we move on? If we had something like number 10, how would we set up our axis of symmetry? Is 8 your b value? So if we don't have a b value, this would be 0. I'm going to put still negative 0, so we remember that we have to put the negative in there, but it would just be 0. Not undefined. That wouldn't change anything. But yeah, x equals 0. So anytime your b value is 0, x equals 0 no matter what. Now if your a value was 0, that'd be different. If your a value is 0, then we have undefined, then this doesn't work. And that shouldn't happen. If we put 0 into x, what would our y value be? 8. So our vertex is 0, 8. Would this face up or down? Down because it's negative. Move on to the next page. So now we're going to kind of do the same thing, but now we're going to have specific values that we're going to graph. So for this, axis of symmetry would be, how would we set this up for this one? Not 0 over 0, but and your axis of symmetry would be what? 0. You don't have a b value, so your b was 0, so this will still be 0. If I put 0 into this, what would my y value be? 0. So my vertex would be the point 0, 0. When you find that vertex, you're going to put that in the middle of your table. We'll do domain and range here in a second. For our table, we're not going to fill in values. For our x's, we're going to go backwards and forwards. So backwards would be -1, -2. Forwards would be 1, 2. No matter what the vertex is, you're always going to do that for your x's. For your y values, we could put each one in, but that'd be a little time consuming. We're just going to use our calculator. Have this up, another over here. In your calculator, go to y equals. Type in the function x squared. So not this one, because that'll just give you square, but an actual x and a square. Press this button for x and then the square. Then go into your table, second graph. So go y equals, type in your function, x, and then square. And then your table, second graph. Find your vertex and the points that, around the points that you put in the table, so -2, -1, 1, 2. Look at those points and you're going to fill in your table using those points. We have 4, 1, 0, 1, 4. Because of our axis of symmetry that cuts it down the middle and mirrors it, really once you have 3 of the values, you should be able to get the other 2 by looking at what you already have. So they should be the same. Once you have all of your values, you're going to plot those 5 points. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Now, let's think back to domains. Remember, that's all of your x values. What would the domain of this function be? It does go to these points, but these have arrows.
So we have to do
It'd be all real
all the
numbers.
numbers.
So you can either put it as XER or put it as interval notation. I'm going to write both, and you choose which one you want to write. So set over notation, X with the curly bracket, the line, X the word E, the word R, or negative infinity to infinity.
Do we have to do the
No, you choose. This one or this one. If you want to write both so you have them both, that's fine. You may not see interval notation on the SOL. You may see more of the set builder notation. So as long as you know how to read it, you're good. What about range? Greater than or equal to 0.
Yeah.
Okay, y is greater than or equal to 0, or this would start at 0 and it would be included and go to infinity. Either or. So axis of symmetry and vertex, once you get that practice in, it's not so bad. Being able to fill out the table is really your calculator doing work. The thing you would need to know is domain and range. Being able to look at the graph and figure out your domain and range. I will say for quadratics, your domain is never going to change. It's always going to be all real numbers, unless it has physical stopping points. Really, we just have to worry about range. Do we have any questions on that? So you did you have a question or were you checking? Okay.
Why is it the one above the 0 and the -1?
This one?
No, actually. The y
Why isn't it what?
-1.
Because if we put -1 in here, it would be in parentheses, and it would be -1 times -1, so we would get a positive. Same. Other questions on that one? Let's do number 2. And then we'll pick a couple negatives and then you'll have time to practice. And I'll show you in Desmos. Oh, before I forget, we need to add one more thing to this. At the bottom of this, put groups. For a quadratic, you will have one of three answers. 1, 2, or none. Roots are your x-intercepts, where it crosses your x-axis. How many roots does this one have? One at 0. So you would write that as an ordered pair, 0, 0. So if you have 1, it touches it once. If you have 2, it crosses through the x-axis twice. If you have none, it does not touch it at all. Right here. Now we'll do numbers. We're going to add the roots at the bottom also, but we'll do that last. Axis of symmetry, how would you find it?
-2 over 1 times 2. Just
-1. And then put it back in that. Yep. Yeah. What did you get when you put it back in? I heard 4. Is it what we all got? Four. Anyone else get anything different? No, we'll go with that. So our vertex would be the point -1, 4. So now we're going to put this function in our calculator and the y equals. Plus 2x, what was the last one? That's fine. The y equals. And then type it, excuse me, your equation. Use this button for x. And then after you get your equation, second graph, find your vertex point at -1, 4. Oh, we didn't fill out the x's, we should have done that. The order in which you do that doesn't really matter. But you would fill in these, so -3, 8, -2, 5, and then 5, 8 for the others. Put it in the y equals. Go into y equals, and you have to type this in. You use this for x, this for squared. Okay. If you try it again, you should get the same value. From those points, you should be able to start recognizing this is going to face up because it's positive. Domain of this would be what? All our numbers. Or XER. Range of this would be what? Y is greater than or equal to 4. So there would be no roots or no solutions. So this would be a case it does not cross the x-axis at all, so it can't have any solutions or roots. I'm going to do this next one. We'll do this next one in the calculator, and then we'll do one in Desmos. Say for this, does this cross the x-axis at all? No. So that's why it's not. Right. If you wanted to, you could go out of order. Like you could write your domain without doing anything because you know it's going to be the same. But it doesn't matter. For our axis of symmetry, how would we set that up? Minus 8 or positive 8. Negative 1, which gives us negative 4. Positive, right? And what would that y become? One. I'm going to say it's not going to be that because it should be able to hit on the graph.
Yeah.
This would be negative 16.
No, that would be.
This would be 16, and this would make it negative. So negative 16 plus 32 would be 16 minus 7 minus 1, negative 1. So don't forget your negatives because that's the easiest way to mess this up. However, you could always double check. So we are doing this part by hand, but if you didn't do this part by hand, if you put this in your calculator and look for where your values start to repeat themselves, you could find the vertex without doing the work. I'll show you guys in a second. Negative x minus x minus everything's negative. So if I just put this into my calculator and I looked at my table of values, these, and I'm looking at these are going up. These are still going up, but now they're going back down. Somewhere the values start to repeat themselves, and that would also tell you where your vertex is. Wherever it stops doing whatever direction you're looking at, that would be your vertex. So negative 10, negative 5, I'm sorry, I looked way too far. Negative 2 and negative 5. Because this a value is negative, it would face down. Domain of this would be, I'll remember this. Range of this would be,
Y is less than or equal to -1.
yeah. So y is, I'll write the set builder first. Y is less than or equal to -1, or in interval notation, that would be negative infinity to -1. What are the roots for this? None, because it doesn't cross the x-axis at all. I do want to also show you how to find roots in the calculator as well, but we'll come back to that. We'll switch gears, do Desmos, and then come back. If you have your computer and it's alive, you can turn it on to look at Desmos. That way we can do this all together. If not, just look at someone else's. Beautiful. Yeah. Just see if you want to move to somewhere where someone has a computer, or you could just watch me, either one. So if you're on Desmos, we'll come back and we'll fill this in here in a minute. Put this one into Desmos, -2x squared plus 4x plus 1.
Will you be able to do this on a calculator?
It does something similar. Yes, it gives you the points. I'm just showing you what points it gives you on Desmos. The function for number 4. -2x squared plus 4x squared. So without doing any work on Desmos, it's going to give you certain points. It's going to give you your roots or your solutions. It's going to give you any y-intercept. You don't need that, but it'll give you that. It will also give you your vertex. So without doing any work, I can see that my vertex is 1, 3, and these are my 2 roots. So we can fill that part in. Also, without doing any work, because it gives us the vertex, we also know what the axis of symmetry is, x equals 1, which means there's an invisible line here at 1, splitting this down the middle. So we can fill in those. are still going to fill in this table, but I'm going to show you how Desmos will help you do that. The name would not change. Looking at this, what would our range be?
Y is less than
3. Y is less than or equal to 3. And you can write the roots that they had as decimals. To find the other points on Desmos, you would do the following. Go into your gear wheel, make this a table. It's going to give you certain points, but we want these points to be something we can graph. Negative 215, you can't really graph, and we want it based around the vertex. So if you wanted to, you could get rid of that point. You don't want it. Because this already goes back to, I'm just going to ignore that one for now. And then go up one more to 3. Now I have 5 points that I could graph. And I'm just going to fill in my table with these 5 points. Negative 1, negative 5, 0, 1, 1, 3, 2, 1, 3, negative 5. I don't know if those are there. It was 1, not negative 1. And then plot those points in graph. The Desmos is nice because it takes care of a lot of the stuff that we have to do by hand. If you got a problem like this, you would not be able to find your roots just by looking at it because they're decimals and it looks like they're decimals. So on Desmos, it will tell you exactly what those decimals are. I'm going to show you how you would find that in your calculator though.
We'll have Desmos.
Yes. You will not have these calculators. If you have your own, you could bring it. And it has to be approved, but most calculators are. So you can bring your own, but you wouldn't be provided with one except for Desmos is still.
Did you say x minus 2?
This, no, it's just x equals 1. In your calculator, write or type this in y equals. I don't think I should have. And instead of going to your table, graph it. Just hit graph, not second graph. To find your roots or solutions, I want to say we've done this before, maybe with linear, but I'm not 100% sure on that. Go into second trace. you're looking for zeros, x-intercepts, roots, those are all interchangeable, but 0. And it's going to ask you to put in a left bound. You cannot find both of these at the same time in your calculator. So pick whichever one you want to do first. I'm going to focus on this 0. So I need to pick some number to the left of this. Give me a number. -5 would work. So if I put in -5 and then hit enter, it will show me that's my boundary line. Now I need a right bound, so something to the right of this that doesn't go past my other x-intercept. 1 would work. If I put in 1 and then hit enter, it's going to give me 2 boundary lines. Then the guess, we don't want to do that. We want the calculator to do the work, so hit enter again. And it would give us that number that Desmos got, but with more decimals. 3 decimals is fine, and round. And then the other one, you would do the same thing. So go back, second trace, go back to 0, but now we're focusing on this one. So we need something to the left of this that doesn't go past the first one. 2 would work. Be careful when it's really close like that, because sometimes it gets weird, but 2 should still work just fine. And then something to the right of this. What number did we say? 4. And then again, we don't want to guess. And it would give us that same number. So in your calculator, it's more work to find your zeros, but it can be done. Do we have any questions on any of this? Finding axis of symmetry, finding vertex, domain range, finding your zeros. For the last bit of class we have, I want you to pick one problem, does not matter which one, and try it. You can use Desmos or your calculator, does not matter.
Yes.
Find your axis of symmetry, vertex, domain range. Also make sure you write in roots and find those as well.